Friends, we are meeting once again for short tutorials on relay setting calculations. We have done one numerical in tutorial 5 about ground relays, and that was not including any transformer. So now this is including a transformer. So little complications we are adding. Right, so let us start with one more numerical on setting of ground relays. So this is our network, my friends. I would like to add here that the presentation style is different. Presentation style is not so simple. The presentation is decorative. Thanks to my old student friend Keval Velani, who is in Hitachi ABB, and his wife Maitri Velani, who has her own business, Techno Art Studio. She has taken pains and helped me to create a presentation. I hope which would be loved and liked by you. The way in which the presentation makes the video more effective. So we have two generators, 80 megawatt, 11 kV, 3-phase 0.85 PF. We have two transformers, 11 by 132 kV, 100 MVA. Then there are many 132 kV lines. One of the lines is having a CT 300/1, across secondary of which there is a relay R1. Obviously, relay R1 is a group of 4 relays, 3 overcurrent relays for RYB and 1 ground relay. Similarly, from bus B onwards, there is relay R2. Once again, 3 overcurrent and 1 earth fault scheme. Then we have 132 by 66 kV transformer, 50 MVA, DY11. Then from bus C onwards, 66 kV lines are emanating. One of the lines is having 300/1 CT, in secondary of which there is relay R3, right? And then 66 kV line is leading to 66 by 11 kV distribution substation. We want to consider this in a very small system. But here we do not want to touch the phase relays. We just want to touch the ground relays, R1, R2 and R3. Phase relays we have done. So we are touching the ground relays because the setting of ground relays is little tricky. So without transformer we have done, we are doing with transformer now. This is the description of the numerical. We have ground relays R1, R2, R3, which are having normal inverse characteristic, and which is also having inbuilt high set instantaneous units. In tutorial 5, we had not high set units. Here we are adding that one more complication, high set units. So tutorial by tutorial will be going on adding complicacies to let you know as to how really in an interconnected system the setting calculations are done. The percentage overreach of instantaneous units of all relays, that is phase and ground both, is 10%. Fault currents are tabulated in the table given in the next slide. You have to determine right now only plug setting, time multiplier setting and setting of high set units for ground relays R1, R2 and R3. In next tutorials, we'll see as to calculate more number of settings rather than only these 3, and not only in one group, in more number of groups, while we will be trying to configure a numerical overcurrent relay. One of its kind, we'll be considering one Raelian version relay REF 615 of ABB, and there we will be doing complete configuration of relays in 6 different groups, how to consider the dynamism of the system and change the group from one to another, and that too automatically using binary inputs. So all those things we will be doing slowly if you remain tuned with Adapt Me. So you have to also suggest setting of high set instantaneous units of phase relays R1, R2, and R3. And we have to assume setting range of ground relays as 10 to 40% in 7 equal steps right now of obviously 1 ampere, because our CT secondary is 1 ampere, and excitation currents of all CTs is 0.05 ampere. This is the table of faults which we will need for calculating time multiplier setting. Different buses A, B, C, D. Fault currents for triple line to ground fault, double line fault, LG fault. Right. So this we will be needing. We start with the solution, my dear friends. TMS of R3. We assume minimum 0.1. No doubt you can assume 0.05 as well. Right? I don't mind if you assume that. I have started with the assumption 0.1. If you assume 0.05, the operation will be at faster. That would be better, obviously. But here I start assuming 0.1. TMS of R2 is also 0.1, my dear friends. TMS of R2 is not different from 0.1 because between R2 and R3 there is a dy transformer, and therefore R2 and R3 are independent. Another disadvantage, if you so want to say, then R2 cannot back up R3 if there is a line to ground fault beyond R3. If R3 fails, R2 will not give backup. Yes, but in 132 by 66 kV transformer, 66 kV side is star connected, and in that star point, if you have got a neutral CT, then in that neutral CT you can have an earth fault relay which will back up R3. So it's not so that completely backup is not there, but R2 will not give backup. R2 is independent of R3. R2 is not to be coordinated with R3. It is not to be graded with R3. So R2 is independent. And therefore, we will go in for R2 with a minimum setting once again. Obviously, we'll go for minimum plug setting. We'll make it as sensitive as possible. 10% sensitivity minimum is available. No doubt 5 to 20% setting range is also available, but we have started assuming 10 to 40%. Now, as settings of R2 and R3 are independent, ground relay R2 is not to be graded, as I told to you. Plug setting of R3 is 10% minimum, right? So TMS of R3 is 0.1, TMS of R2 is 0.1 because they are not to be graded, right? Time multiplier setting, we go for minimum. As I told you, you could have gone in for 0.05 also. TMS R2 also you could have gone in for 0.05. I have gone in for 0.1. So TMS are same because there is no grading. Similarly, plug settings are also same because there is no grading between R2 and R3. So PS of R3 10% minimum. PS of R2 also I go for 10% minimum. However, PS of R2 in primary terms is 0.1, that is 10% of 1 ampere plus 3 times 0.05, that is 3 excitation currents of 3 line CTs. So it will be 75 ampere in primary terms, but that is not to be graded. So PS of R2 is also 10%. So now R2, R3 both are available. Plug setting of R2 10%, plug setting of R3 10%, TMS of R2 0.1, TMS of R3 0.1. Out of 3 relays, 2 I have immediately, hurriedly found out. You see, very simple, so to say when there is a transformer, but you have to remember that when there is a transformer, you should not make a mistake. Now I have to go for R1. Between R1 and R2, there is no transformer, my dear friends. Between R1 and R2, there is no transformer. So they are to be graded. Therefore, I will go in for grading between R1 and R2. So what is PS of R1? It is 1.3 divided by 1.05 of PS of R2. It has to be greater than that. PS of R2 is 10%, so 0.1 plus 0.15, that is 3 times 0.05 added, so that gives me 0.25. 0.25 in primary 300 bar 1 CT will be 75 ampere, and 1.3 divided by 1.05 of 75 will be 92.85 ampere in primary terms. And if I go to secondary 300 bar 1, because R1 is also 300 bar 1, CTs for R1, R2, R3, all the three CTs are 300 bar 1, so it takes me to 0.3095, right? Because 300 bar 1, roughly 100 ampere is 33%, so 0.3095 ampere is the current in secondary. Now, current through R1 is not 0.3095, 0.3095 minus 0.15, because 0.15 of excitation current is to be deducted. So, current flowing through R1 is 0.1595. And 0.1595 happens to be 15.95% of 1 ampere, and therefore PS of R1 is selected as 20%. Next 5% I am going in for. Should have the numerical relays, the steps are smaller and I could have gone in for different step, maybe 16% I could have selected. But right now I do not go to that extent. When we go to numerical relay, we'll see whatever is available in that numerical relay, we'll try to adjust and we'll try to consider. Right now, we go in for this because we want to understand the principle. You see, 15.95% I have gone in for 20%. Had I numerical relay, I would have gone in for 16%. That is only the facility in the relay. Principle remains the same. Philosophy remains the same. So let us go in for understanding the philosophy. Now we have to find out the setting of ISET units, right? Obviously, before going for TMS, we have to find out setting of ISET units of ground relays. Formula is 100B, 100 minus A. What is B? B is the fault current, say for ground relay, line to ground fault current at next bus. So what is the next bus at R3? Let me check up. What is the next bus at R3? Next bus at R3 is D. And for D, my dear friends, my fault current is 1676. Remember, right? Similarly for C2560 and for B2024. So 1676 I have to consider. So I am considering 1676, right? So 1676 I have considered. But that B is in secondary terms. So 1676 divided by 300. CT ratio I have to remember. And 100 minus A is percentage overreach, which is 10% given. So if you so consider, the calculation gives me 6.2 ampere. 6.2 ampere happens to be 620% of 1 ampere. Therefore, I set setting I will consider higher. Obviously, we have to go for higher. I cannot go for lower because otherwise overreaching will take me to the next section. So that should not happen. 650% when I select, it will not protect 90%. 10% overreach means the relay should protect up to 90%. But when I'm selecting 650% instead of 620, it will not be 90. Probably it will be 85 or 80. Okay, no problem, because remnant 20% or 15% is going to be taken care of by the time delayed unit. So I'm not worried about that. The protection is going to be there, right? So R2, I have not to find out specially because R2 and R3 are independent once again. Therefore, R2 ISET setting I consider minimum because setting range for ISET unit is usually 400 to 2000% in steps of say 50%. So I consider minimum 400% for R2, and for R1 because my fault current is 2024. 100 minus 2024 by 300 CT ratio by 100 minus 10, that is 90, 7.49, 749%, that is high set setting, I will go for 750% for R1. That is the R1, R2, R3. I have found out the setting ranges. So now I have to go for TMS. TMS R2 and R3 already found out 0.1, 0.1. Right? So only TMS of R1. Volt current is 2024, right? At bus B. Volt current at bus B is 2024. Let me check up once again for you to remember and for me to check up. Volt current at bus B is 2024, which is the highest fault current to coordinate R2 and R1. So for that 2024, I go further, my dear friends, and I will be taking that to secondary. 300 bar 1 will give me 6.746. Current through relay will not be 6.4746, but it will be minus 15, a little less. No problem. I mean, not much different, but yet I have to calculate 6.6, and 6.6 is 660% of 1 ampere. Now my high set setting for R2 is 400%. 660% is more than 400%. So R2 will not follow that inverse curve. R2 will operate instantaneously, that is maximum 3 cycles. I take 0.06 seconds. 20 millisecond 1 cycle, 60 millisecond 3 cycle, 0.06 for R2. Therefore R1 0.25, that is discrimination margin, which I usually consider I add. And therefore TMS of R1 is 0.31, that is required into log 1020. Why log 1020? Because PSM of R1, what is going to be PSM of R1? 2024, fault current is same. 2024 upon say 300. So it is going to be 6.746. 6.746 minus, sorry, yes, 2024, 6.746. 6.746 minus 0.15, 6.6. Now, 6.6 will not be 660% of 1 ampere. 6.6 is the current through R2. But R2, my setting is, I think, 15%, if I mistake not. That is the plug setting of R1 I have selected as 15%. Let me check. PS of R1 is 20%. Sorry, 20%. So PS of R1 is 20%. So if I take 20%, that is 6.6 divided by 0.2. That will be 5 times 6. So 30. So 30 PSM I cannot take. Maximum 20 I can take. So 0.31 into log 1020 divided by 3. So my TMS of R1 will be 0.1344. And I select 0.15. Next 0.05 step. So TMS is also found out. Right? I have also been asked to find out the high set setting of phase over current relays. For phase over current relays, the fault currents are 1602, 2144, 2094 on bus BCD. That is B2094, C2144, D1602, 3 phase fault currents. And I have to consider secondary current. Therefore, I have divided by 300. For R2, I have taken one more thing. Not only divided by 300, but fault is on bus C. But between B and C, there is a transformer. So transformation ratio I have to consider. Therefore, 66 by 132 factor is coming because of transformation ratio. So if you consider all this, my setting of high set unit for R3 is 600%, R2 is 400%, R1 is 800%. So I have found out everything. If I summarize the setting, R3 plug setting is 10%, ground relay, R2 10%, R1 20%, ground relays TMS are 3.1, R2.1, R1.15. High set for ground relays 650% for R3, 400% for R2, 750% for R1. For phase relays 600% for R3, 400% for R2, 800% for R1. So this is what I have found out, and this is how you can solve the example on ground relays. I hope, friends, you might have enjoyed these settings, because this is what is required to be done in the field exercises. So in these tutorials, we are not much talking on theory. Uh, Theory, if you want to see, my book is also available, Power System Protection and Switchgear. It is uh, published by McGraw-Hill International, right? A very well-known publisher, international publisher. So it has been published by them. And if you search in Google or anywhere, write my name Bhuvanesh Oza and write Power System Protection, you will get that book. The book is available in hard version. It's also available in e-copy. All theories and everything are given very nicely there. Many people have praised that, because it is a book based on practices. It is not for only students. Students are learning theory. I am not talking about theory. I am talking about the practice part, which you will need while you are doing your job, right? So that theory portion I have not touched. If you want to learn theory, I mean, book was published in 2010. Now it is 2021. Many more things have come in new technology. So if you want to learn the latest technology, my modules are also there. Adapt Me, the app, has uploaded 3 of my modules right now. 4th is on way. 3 modules. First is elements of power system. Second is fault current calculations and substations. And third is protection of transmission line using overcurrent and earth fault relays. There you will get lot much of theory, all such numericals, and you will also get the questions, right? And you have to, I mean, questions just to be tick marked. So multiple choice questions, etc. So you have to calculate the questions. So you will become expert in power system protection if you go through those modules. And those modules give you many more things. They give you what is your analytical capability, what is your logical capability, what is your mathematical capability, right? What is your memory? How far is, how good is your memory? All these analysis is given at the back end of the uh, module. Uh, so you have to subscribe for those modules if you want to learn more and more. But here we are trying to, at free of cost, the YouTube videos. Here also we are trying to cover a lot, my dear friends. So friends, with this we come to an end of this tutorial, tutorial number 6. If you want to learn power system protection, 5 videos have already been uploaded. You can search for Adapt Me in YouTube and you will get all my videos, right? So please remain tuned with Adapt Me. Go to Adapt Me app in YouTube uh, and subscribe for our app. Also like my videos, right? And share videos to as many friends as possible, because it is said that Vidyadan, the education, if you impart to somebody, it is the best kind of giving. दान जो सबसे श्रेष्ठ है, the thing which is the best, to give the best. Money is not best, because money will go away, people will spend. Vidya will remain forever with you. So friends, share these videos to your friends, right? And my friends, I have got some 70 hours of teaching in power system protection with long 42, 43 years of experience. some 29 years in teaching, some 12 years in industry. Right now also many industries are calling me for training. Many educational institutes in and out of Gujarat, many industries in and out of Gujarat and out of India, abroad also people are calling me. So with all that experience, I have some 70 hours of teaching material. So if I give you half an hour of video like this, short tutorials, some 150 videos will come. This is only 7th. Some 150 videos will come. Stay tuned, my dear friends. Keep in touch with Head Up Me. Thank you, friends. Good day.